Hi, today I will explain the second part of quantum teleportation, which is quantum communication protocol to teleport to one arbitrary quantum state to somewhere by sending two classical bits. First of all, there is a third party called Mickey Mouse between Bob and Alice. The Mickey Mouse creates an entangled quantum state of two qubits. The entangled state could be one of a bare state. Then he sends the B portion to Bob and A portion to Alice. So Bob and Alice have each entangled qubit. Then Bob considers any arbitrary quantum state that he wants to teleport to Alice. How does Bob possibly teleport the arbitrary quantum state to Alice? Bob has two states. One is the entangled qubit, and another is the arbitrary quantum state. He changed the basis of his state to bare state. For example, his state cat 00 will change to the superposition of a bare state, cat phi plus and cat phi minus, and so on. By some algebra, Bob's state changed to the superposition of a bare state, and Alice's state changed to the superposition of four possible arbitrary quantum states by quantum operator I, Z, X times Z. Each bare state is correlated with the Alice's one of arbitrary quantum state. For Bob to teleport the arbitrary state, what does Bob have to do? He applies the bare measurement to his four bare states. As a measurement result, he will have two classical bits, C1 and C2. The probability of getting C1 and C2 is 25% because four bare states are uniformly superposed in Bob's place. But this measurement will cause the change of Alice's state. Her measurement will collapse to the state correlated with the Bob's post-measurement state. After the measurement, Bob has two classical bits, C1, C2. Then he sends Alice two classical bits over classical channel between them. Once Alice receives Bob's classical bit, she started decoding her collapsed quantum state to get the arbitrary quantum state. Based on the two classical bits she received, Alice knows which quantum operator she should apply. So she picks the quantum operator UC1, C2. Then she applied the operator to the state, cat A, C1, C2. Once she applies it to her state, the state cat A, C1, C2 change to the arbitrary quantum state that Bob wants to teleport, cat psi. It does not violate the theory of relativity. Any information cannot be faster than the speed of light. This quantum protocol does not instantaneously teleport the physical state from Bob's side to Alice, like the Star Trek movie. Instead, once Alice received the classical bits from Bob in her place, she telecorrects her state to the arbitrary state with the given classical information. So by using two resources, one entangled state of two qubits and one classical channel to transmit classical information, but Bob can send any arbitrary quantum state to Alice. For example, Alice receives two classical bits 0 and 1. By Bob's measurement, Alice's state collapsed to the state cat A, 0 and 1, that is the bit flips quantum operator, x times the arbitrary quantum state cat psi. But the operator x times arbitrary state cat psi is alpha cat 1 plus beta cat 0. Alice knows which quantum operator she should apply by the two classical bits 0 and 1. She finds the right quantum operator U0 and 1. The operator U0, 1 is the bit flips operator x. Once Alice applies operator x to her state, she gets back the arbitrary quantum state that Bob wanted to teleport. This is an example of quantum teleportation and explanation. Thank you for watching. God bless you.